Welcome back, and today we are working with horizontal alignment, and that's looking at the plan view and putting in your curve data and things of that nature. And let's start looking at this. And the horizontal plane, again, that's whenever you're looking down at the earth. And we'll go in here and show you something real quick. It looked like something like this. You're in an airplane looking down on Earth. The Earth would be your horizontal plane looking down on it. And that's where we're going to get. And this alignment is getting everything lined up accurately and precisely. So let's go back and show you a few things about this. Now, a plan layout. It defines the location, the route, extents, and characteristics of a proposed highway or road. Okay? And that's what we're going to do. Alright? And we have the initial survey and additional surveys. This is some of the things. Basically, when you're going to design a road in horizontal alignment, you are going to find the center of the road. That center line is also called the transit line. Okay? And you're going to use a route survey. We've already looked at that earlier in our survey portion of the course. And it's going to be an open survey, more than likely. And you can use bearings. Your distance and station points are recorded. Additional surveys, that would be, of course, like your easements, your right-of-way of like your any type of utility that has to come through. Could be gas lines, it could be electrical lines, as far as the width of the road, the profile, the cross-section of it, things of that sort. And again, there's many more things we could look at. There are two ways to really get a curve and to be able to distinguish it, and the first option is called using station points and curve data. Okay? The second option is using points of intersect and using a curve radius, and I'll show you those here in just a second. Now, when we use curve data, there are, of course, you have to have station points, and these are, a full station is 100-foot increments. Intermediate station points are 50 foot. So if you ever see that, you'll always know that if you have station points on there, they're 100 foot in distance apart. Now on your curve data, you're going to have three major things that you're going to see, and one of them is point of curve. That's where the curve starts. Point of tangent is where the curve goes back into a straight line, and point of reverse curve is when you've got two curves that come in together and meet. Okay, they intersect one another. So let's go there and take a look at that real quick. And here's this map, and I've actually got it on AutoCAD just to make it a little bit more simplified. So you know that you see these little dashes, those are your 100-foot station points. Okay, and you all see here 1900, that'd be 2000, 2100, 2200, 2300. There's your 100-foot station. Alright. Now, in this curve data, we'll notice that the road is going northwest, so it was surveyed like that whenever we were traversing. So we're going in this direction here. So it makes sense that our point of curve, this is where we're going to start our curve. So it's a straight line, north 84 degrees, 15 minutes west. And at this point right here, we're going to start putting a curve in. And that is at 1900 station point. So when you see the station point, this is your hundredths right here. So it's 1900. So like over here, this 25 would be 2500. This would be 2523.4 foot. Okay, so this is always in your 100 spot. So now we're coming along through here. We hit this point of curve. We're going to start a curve, and down here is the curve data for this. Now this is the first option, is using curve data. And on this point of curve, let's go down here and read what it's got. This is a radius of 500. So right here, this curve is 500 foot radius, which I put that on there. So there's our curve of 500 foot radius. Delta angle is 42 degrees and 10 minutes. What that means is from this line to this line, it's 42 degrees and 10 minutes. If you put in there and done your angle, it would be from here to here. Okay? The next thing is length. That is your length, curve length. That'd be if you was coming around through here and you were measuring this curve length, it's going to be 400 foot. And if you'll notice, 1900 to 2300 is 400 feet. Then you have degrees, which is 10 degrees, 32 minutes, and 30 seconds. And what that's saying is, you see how these station points are in here? What that means is the distance between each, the angle between each. So if I were to come down here and put this line up here and catch it right there, that would be 42 degrees and 10 minutes between that to this. Okay? And it would be the angle between each of them. So if you come up here, it'd be that angle right there. It'd be the same degree. And of course, the last one here, it would be going through that point. So it'd be the angle between each one of those should be 10 degrees, 32 minutes, and 30 seconds. The delta angle is from the first one to the last one, which is 42 degrees and 10 minutes. Okay? So now, that's what that curve data means. Now sometimes you'll have, and you'll notice this thing's coming all the way around here and stopping right here. And this is a point of reverse curve. It's going into another arc. This is where it intersects that. And this is the point of reverse curve. That means we're going this way, then we're turning and going the opposite way. Okay? So, there's a couple more things I want to show you here. Sometimes you'll also have this. You'll have what we call a chord. Now, a chord is just a line that intersects a circle, right? That is a chord. Now, you'll have on there, sometimes you'll have a chord length, which would be the length of that line. And also, sometimes you'll have a chord bearing. And that would be like from point of curve down to point of reverse curve. It'll give you the angle using a bearing on there. And you'll see that in one of the drawings we have for you to do in this assignment. So that's another thing that you guys need to remember. But anyhow, this point of reverse curve, it hits here and it goes back the other way. And it's going to stop at the PT, which is the point of tangent. This is where it stops curving and goes back into a straight line. Okay? And it's the same song and dance. I'm going to come up here and put a 3-point arc on here. And I'm just going to show you all just basically what's going on here. We'll eyeball it as close as we can with this. It's not going to be a very good arc. But anyhow, just imagine this circle in here. And it's coming right around through here, all the way up and around. And it's a 700 foot radius, as this one was a 500 foot, so it's going to be a large radius. And the delta angle, again, is from the point right here to this point. The length of it, if you count it up, 2300 to 25, so 23, this is the length of it, the length of this curve. It's going to be 500 feet, and then the angle between each one of these is going to be 8 degrees and 26 minutes. Now, let me show you something else on this. In our homework, let's see if I can find it here. You've got this little project in front of you, and this is North Bethany Creek. This is a replat of partials 1 and 2. This is a plat that we're looking at, and there's some questions to it as well. Let's open some of those up. The drawing scale is, and you guys, that's pretty easy to find on here. Just get in there and figure out what that drawing scale is, and you should be able to find that pretty easy. And north is toward the blank of the sheet. Where is my north arrow? So you'll have to go in there and find all of that good stuff. And if you'll notice here, it's 1 inch equals 40 foot, and the north arrow is going toward the top of the page. The drawing sheets, how many sheets are they? Should be down here, sheet 2 of 3. And let's get into one more question that might help you, and I want to show you a couple things about some of this curve data, and I'll let you guys find the rest of it. And make sure that you always, when you start looking at a map, read everything is always my best advice, especially the legend, and if there's any notes associated, read those. Now, you'll see here is the curve data. You remember we talked about it. We just got done speaking of curve data. So let's go in here and like this big curve right here. I'm going to hit Control plus and blow this thing up if it'll let me. It's not wanting to let me here. Well, anyhow, this is C12, and if you come down here, you got C12 data. Here we go. That's why I was looking for my zoom. There we go. That way I can actually see what's going on here a little bit better. So there is C12. And now I just need to slide down and be able to take a look at this, my curve data. There we go. So we see C12, and the length of it is 136.03. But anyways, right here is my curve 12. Looks like to me it's 40. The delta angles is 46 or 48. It's kind of hard to tell right there. I won't count you wrong if you don't get that exactly right, because it's hard to see that. I think it's 48 degrees, 24 minutes, 31 seconds. The radius is 161 feet. So this radius of this curve is 161 feet. Okay? The arc is 136.03. So that's this distance right here. If you went around through here and measured this, it's 136.03 in length. The chord is 132.02. Remember, that would be the start of it to the end of it. Now let's take a look. There's the chord in southwest. So we are coming from here and traversing down this way. So it's southwest. So it's 132 or 136.03 is the arc. The chord is 132.02. A straight line here would be 132.02. And it's going south 60, 28 degrees, and 32 minutes west. And that gives you all the information that you need for that curve right there. And that's using curve data. So, you know, this right here is our transit line. This is the center of our road, but you're noticing the curve data also works in property. I mean, it's the same thing. You're surveying, and that curve data works exactly the same if you've got a curve on a piece of property to identify it. So those are a few things that you need to look at, and there's a lot of questions on here. And again, read your notes. Like PUE denotes what? Well, if you come back in here, guys, it'll tell you, like in the legend here, PUE denotes public utility easement, okay? And that's just giving you PUE. It tells you how much distance from the center line, how much distance a utility company has to come in and do repairs on whatever utility that they're bringing in through the property. So make sure you read your map well and go in there and answer those questions for me and submit that for me this week. If you have any questions on that. Now, there is one more thing before we close on this. There's another option which is called point of intersect. Okay? So let's get to that one. Now, point of intersect is used quite often in curves to be able to lay out a curve in the field. Point of intersect is this. It's just you're bringing your lines. When you're doing your transit, you're shooting that transit line up there, and you're actually hitting the point where those center lines would meet. And when you hit those, that's a point of intersect. And then, of course, you have the total distance and the bearing or azimuth to where it hits, and that point of intersect, you'll be able to have also the radius of the curve. And whatever you offset that curve, when you offset that center line, if it's a 300 foot center radius, just offset both lines 300 foot at the center point, and then you can draw in your curve. Okay, so there's two main ways to make a curve, and those are the two different ways. Again, if you have any questions or concerns, please contact me.